Hello, welcome. Today we are going to be looking at set theory. We are going to be looking at set theory. What is a set? A set is a well-defined collection of objects or things. A collection of objects or things. You can talk about a set like you say a set of whole numbers from 2 to 10. That means 2, 3, 4, 5, 6, 7, 8, 9, 10. So the elements of the set of a whole number from 2 to 10 are 2, 3, 4, 5, 6. You separate them with commas. So a set is a defined collection of things or numbers. A set of a whole numbers from 2 to 10. This is how you express a set. So A here is a set. This A is a set. And the collection must be contained in a curly bracket. These are the elements of this set A. So the elements of set A are 2, 3, 4, 5, 6, 7, 8, 9, 10, separated with commas. So this is an example of set representation. You can also represent a set in this form. P. The set is always represented in a capital letter. P is equal to set of, whenever you see curly bracket, it means set of prime numbers from 1 to 20. So in that case, you can still represent this set showing the prime numbers itself or in a statement form like this. Just the same way you can put this one and represent this as set of what? Whole numbers from 2 to 10. So it can be in statement form or it can be in the real form like this. So this is how you represent a set. You write a capital letter representing the name of the set. Then you put the elements, the collection of objects inside the curly bracket separated by commas. That's why we say that a set is a defined collection. See, it's not one thing, but collection of objects or things. It can be numbers, it can be alphabets, it can be anything. Now, the elements of a set are the items contained in a set. You can see the items that are contained in this set. These are the elements of set A. And it can be represented with this type of E, while a non-element is represented with this. So consider these two sets, sets R and set Q. The elements of set R are 1, 2, 3, 4 to 8, whereas the elements of Q are 9, 11, 12, 13, 14. You can write that 2 is an element of R. You can see the way we represented the 2 elements of R, because 2 can be found in R. And you can say that 4 is not an element of Q, because if you check through this collection, you cannot see 4. Cardinal number of a set is the number of elements in a set. So if you come, say this set B, having this collection 2, 4, 6, 8, you can say that the cardinal of this set B is 4 because the number of elements are 4. 1, 2, 3, 4. So cardinal of B is equal to 4. C, you can also get the cardinal of C by counting the number of elements. If you count, you are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. It's actually 9. But then F is repeated twice. So anyone that is repeated, you don't count it, you count it as 1. So you only have 1, 2, 3, 4, 5, 6, 7, 8. So the cardinal of C, the cardinal of set C is 8. A subset is a set within another set. A subset is a set within another set. So consider these two sets. This is set G containing 3, 5, 6, 7, 8, 9, 10. And another set H containing 5, 7, and 8. You can see that this 5, 7, 8 is also here. 5, 7, 8. So you can say that this H is a subset of G. H is a subset of G, and you can represent it using this. H is a subset of G. The bigger side is representing the superset, whereas the smaller side is representing this subset. Now, every set is a subset of itself. Every set is a subset of itself. Let's explain this. Every set is a subset of itself. So let's talk about this set. With that, it brings us to another point known as power of a set Every set is a subset of itself. Say set B to be this 1 and 3. What are the subsets of this? Subset is any set that is contained in a set. So we can say that the subsets of B are itself. This is a subset of B. Also, subset 1 is also a subset of this because it is contained here. Also, 3 is also a subset. And finally, empty set is also a subset. So whenever you want to get a subset of a given set, these are the subsets. You have 1, 3, which is because we say that every set is a subset of itself. Then we'll have only 1, we'll have only 3, then we'll have empty set. So B is actually having how many subsets? It's having 4. So given any set, the number of subsets is known as the power of the set. It's known as the what? Power of the set. So how do you know the number of subsets for this? You simply count the number of elements that it has. Just do 2 to power. 2 to power the number of elements. So this is going to have 4 subsets. So let's say that you're given 1, 3, 4, and you're told to find the subset. Without writing them one by one, just say 2 to power 3 because you have how many elements? 1, 2, 3. So it's going to have how many subsets? 6. So how do we identify these subsets? Once you already know that the subset will always be 6, it's easier for you to write. So you can always know that every element is a subset of itself. So you have to write this first. Then you have to write only 1. Then you have to write only 3. Then you have to write only 4. That's how many? 1, 2, 3, 4. Then you have to write only 1 and 3. Then you have to write only 1 and 4. Then you have to write empty sets. So making it 1, 2, 3, 4, 5. Am I making mistake? Where is the mistake from? 2 to power 3 is what? It's not 6. Yes. That's where the mistake is. 2 to power 3 is 8. You understand?
Yes.
So this has to have up to 8 subsets. So we have 1, 2, 3, 4, 5, 6, 7. So it's remaining 1. So we need to also have the subset of what? 3 and what? 4. So these are the subsets. You understand? It must have 8 because we have 1, 2, 3. It's going to be 2 to power n, which is 2 to power 3. So let's say now that we have 4 and 5, and we are told to find the power of this set. It's going to be 1, 2, 3, 4. So it's going to be 2 to power 4, which is what? 32 back. So if you build the subsets of this, you're going to get up to 32. 2 to power 4 is 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8.
16.
8 times 2, 16. Sorry. So this should be 16. So if you build the subsets of this, you're going to get up to 16 subsets. So very important, take note. So that is how you get the power of a set. Power of a set is simply telling us the number of subsets that a set has. So all these are subsets of this because all these are contained inside B. 1, 2, 3 is already there. Okay, this is the one I was using. 1, 3, 4 is already there. 1 alone is already here. 3 alone is already here. 4 alone is already here. 1, 3 is already here. 1, 4 is already here. Empty set is the subset of every set. 3, 4 is already here. Every set is a subset of itself. So that is set theory. Make sure you understand. Every set is represented with a capital letter, and the contents or the collection must be enclosed in a curly bracket, and the elements must be separated with commas. These are the elements. And subset of an element is another subset of a set is another set that contains the same element or that contains elements that are inside the main set. So this is the superset and these are the subsets. Power of a set is simply gotten by saying 2 to power the number of elements of the set. And the power of a set is also telling us the number of subsets that a set will have. The power of a set is telling us the number of subsets that a set will have. If you like this video, please click on the subscribe button, like and share it. Thank you.